Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be solving absolute value equations. This is part one of a two-part lesson. So remember from previous grades that the absolute value of a number is that number's distance from zero on a number line. For example, the absolute value of negative 5 is 5 because negative 5 is 5 units from the number 0. Now, we can solve an absolute value equation like the absolute value of x equals 5 graphically on the number line because we want to know this is our absolute value parent function, absolute value of x, which is just a V-shaped graph going through 0, 0. We want to know where does that function equal 5. So let's go on the y-axis to 5. 1, 2, 3, 4, 5. And notice if I draw a horizontal line, y equals 5, my absolute value function would intersect that line 2 times, here and here. So 1, 2, 3, 4, 5, negative 5, 5, and positive 5, 5. So that means this equation has 2 solutions, x equals negative 5 and x equals positive 5. All right, now let's talk about modeling absolute value equations and their solutions on a number line. So if you had in problem A, the absolute value of x is equal to 3, that literally means what number or numbers are 3 units away from 0. Why 0? Well, because this can be rewritten as absolute value of x minus 0 is equal to 3. All right, so here's 0. So I want to know what numbers would be 3 units away from 0. Well, 1, 2, 3 right here. That would be one of our solutions at positive 3. And 1, 2, 3. Here is another solution at negative 3. So both of these values are 3 units away from 0. So I'm going to write my solution in braces because these are both x values. So negative 3 and positive 3 would both solve this equation. All right, let's say we had the equation absolute value of x minus 1 is equal to 4. That literally means what number or numbers are 4 units away from positive 1. All right, so here's positive 1 on our number line. That's positive 1. And so I want to count 4 units to the right and 4 units to the left. So 1, 2, 3, 4. Here's one of my solutions. And then 1, 2, 3, 4. Here would be my other solution. So this would be negative 3, and this solution is 5. So when I write my solution set here, there are 2 numbers that would make this equation true, negative 3 and positive 5. All right, problem C. We have an equation that says absolute value of x plus 2 is equal to 3. This literally means what number or numbers are 3 units away from negative 2. So negative 2 would be right here. So if I go 1, 2, 3 units in this direction, there's one of the solutions. And then 1, 2, 3 units in this direction, there's another solution. So my solution set here would be negative 5 and positive 1. These 2 values of x would make the equation true. All right, problem D. We have the absolute value of x minus 5 is equal to negative 4. So this is saying what number or numbers are negative 4 units away from 5. Well, we have a problem here because distance can't be negative. So for this problem, I'm going to say that there is no solution because distance can't be negative. So I would simply use the no solution symbol for my answer. All right. Now, the next thing I want to talk about is how to write an absolute value equation. So your general form of an absolute value equation is the absolute value of x minus c is equal to d, where c stands for your center and d stands for your distance. So let me show you how that works. Example 2. The graphs below represent the solutions to an absolute value equation. Write the absolute value equation that would produce the two solutions. So to write the absolute value equation, you want to identify the center and you want to identify the distance. And then you can use those two values to write your absolute value equation. So our solutions are 2 and 8. So 1, 2, 3, 4, 5. So they're 6 units apart. So the center would be 3 units from the first point. So 1, 2, 3. So here's our center. Our center is at 5. Now, to get your distance, count from the center, how many units is it to each solution? So 1, 2, 3. So our distance is 3. Now, to write the absolute value equation, you would simply say x minus the center, the absolute value of x minus 5, is equal to the distance. In other words, what two numbers are 3 units away from 5? All right, let's try another one. We want to identify the center and the distance, and then write an absolute value equation that would produce these two solutions. So our solutions in this problem are -9 and -3. So 1, 2, 3, 4, 5, 6. So they're 6 units apart. So I need to go 1, 2, 3, and that tells me our center is at -6. And our distance is again 3 units. So our equation would be absolute value of x minus -6 equals 3. And then I want to simplify that to absolute value of x plus 6 equals 3. So what two numbers are 3 units away from -6? All right, problem C. Identify our center and our distance. So 1, 2, 3, 4, 5, 6, 7. So these numbers are 7 units apart. So my center would be 3.5 units from -1. So 1, 2, 3.5. My center would be right here at 2.5. And my distance would be 3.5. So my absolute value equation would be x minus 2.5. The absolute value of x minus 2.5 equals 3.5. All right, pause the video and try problem D on your own. When you're ready to check your answer, press play. All right, welcome back. On this problem, I said that the center was at -2 and the distance was +4. So my equation was absolute value of x plus 2 is equal to 4. All right, now let's get into solving absolute value equations. When solving absolute value equations, the first thing you want to do is isolate the absolute value expression by using inverse operations. So in this example, we have absolute value of 5 minus 2x minus 11 equals 0. We want to isolate that absolute value of 5 minus 2x. So I would add 11 to both sides. And when we do that, we get absolute value of 5 minus 2x equals +11. All right, step 2, create two equations of the form ax plus b equals c and ax plus b equals opposite c. So I'll do that now. Step 2, 5 minus 2x equals 11. And 5 minus 2x equals the opposite of 11, or negative 11. Step 3, solve each individual equation. So here I would subtract 5 to get negative 2x equals 6, and then divide by negative 2. So 6 divided by negative 2 gives me negative 3. On the other side, subtract the 5. Negative 2x would equal negative 16. Divide by negative 2 to get positive 8. Then you're going to express your final answer using braces, because both of the solutions are x values. So negative 3, 8. There's your solution. All right, example 3. Solve each equation below. In problem A, we have 1/3 times the absolute value of negative 3x minus 3 is equal to 8. Now, I want to isolate my absolute value expression. So to get rid of the fraction 1/3, I'm going to need to multiply both sides by the reciprocal of 1 over 3, which is 3 over 1, or just 3. So when I do that, 3 times 1/3 cancels out and leaves me absolute value of negative 3x minus 3. And on the other side, 8 times 3 gives me 24. Now, once you have your expression isolated, you're going to rewrite it as negative 3x minus 3 equals positive 24, and negative 3x minus 3 equals negative 24. Then solve each of these equations. So step 1, add 3. So negative 3x equals 24 plus 3 is 27. Divide by negative 3 to get negative 9. On the other side, add 3 to get negative 24 plus, that'd be negative 21. Divide to get positive 7. So my solutions are negative 9, positive 7. All right, problem B. Now in problem B, to isolate our absolute value expression, we're going to have to get rid of this 14 and this negative 2. So let's get rid of the 14 first. So we're going to subtract 14 from both sides. So if I subtract 14 here and 14 here, that will give me negative 2 absolute value, 2x plus 3 equals negative 16 minus 14, negative 30. Okay. Now we can divide both sides by negative 2, and that will give us absolute value of 2x plus 3 equals positive 15. Once you have your absolute value expression isolated, now you can rewrite this as 2 equations. Now what I'd like you to do is pause the video and finish this problem on your own. When you're ready to check your answers, press play. All right, welcome back. So I got 2x equals 12, therefore x equals 6. Over here, 2x equals negative 18, therefore x equals negative 9. So my solutions are 6 and negative 9. All right, problem C. We have negative 3 times the absolute value of x plus 1 over 2 is equal to negative 12. So I want to start by dividing both sides by negative 3. So that would leave me absolute value of x plus 1 over 2 equals negative 12 divided by negative 3 is positive 4. Now, take your equation and split it into 2 pieces. So x plus 1 over 2 equals 4. X plus 1 over 2 equals negative 4. All right, to get rid of the 2, I'll have to multiply both sides by 2. And when I do that, that will leave me x plus 1 equals 8, and then subtract to get 7. On this side, I want to multiply both sides by 2. So these twos cancel out and leave me x plus 1 equals negative 8. Subtract 1 to get negative 9. So 7 comma negative 9. All right, problem D. 3 minus the absolute value of x plus 4 is equal to 5. So let's get rid of this 3 first. We'll subtract 3 from both sides. So that would leave me negative 1 times the absolute value of x plus 4 equals 2. Now we're going to divide both sides by negative 1 to get rid of that negative. So the absolute value of x plus 4 equals negative 2. Now, I'm going to stop right there because I can already tell this equation has no solution, because this is saying what two numbers are negative 2 units away from negative 4. Distance cannot be negative, so this problem has no solution. All right, last example. A machine fills oatmeal containers with 32 ounces of oatmeal. After the containers are filled, another machine weighs them. To sell the product, the container's weight can differ by 0.5 ounces. Write an absolute value equation which represents the limits of the weight of the container and solve. So in this problem, your center, or in this case, it's the ideal. So the ideal here is you want to fill each container with 32 ounces. However, your distance can be off just a little bit in either direction, and they're saying that the container's weight can differ by 0.5 ounces. So if I wanted to write an equation for that, remember you take the absolute value of x minus the center, which in this case was 32, is equal to the distance, which was 0.5. So if I was going to solve this, well, let me box that in because that's one of my answers. It wanted us to write an equation. If I was going to solve this, then I would split it apart and solve. So here I would add 32. So the container could weigh 32.5 ounces and be okay. And here I would add 32. And I would get 31.5. So the containers could also weigh 31.5. So 31.5, 32.5 solves this equation. And that concludes today's lesson, Solving Absolute Value Equations, Part 1.